Alright, so this problem says an empty parallel plate capacitor has a capacitance of 20 microfarads. How much charge must leak off its plates before the voltage across them is reduced by 100 volts? Okay, so now, so let's say the charge initially was that, and the voltage was this. Okay. Now, so this is the capacitance. Charge divided by the voltage is the capacitance of the capacitor. Okay. Now, this much charge will leak out, and the voltage will drop by this much, which will be, it'll drop by 100 volts. That's what they're saying. Okay, the voltage is dropped by 100 volts. So whatever the new charge left divided by the new voltage, that is still equal to the capacitance. Okay, right. So this ratio should equal this ratio, which is equal to the capacitor. Okay. So okay. So let's see what does this say to us. Okay. So what this saying is Q plus delta Q times V equal to Q times V plus delta V. Okay, so QV plus delta Q times V equal to QV plus Q times delta V. Okay, that cancels. And so delta Q times V equal to Q times delta V. And what that is saying is, so Q over V equal to delta Q over delta V. And that's equal to the capacitance. Okay, so what this equation is telling us, if this much charge leaks out, the voltage drop, the charge leaking out divided by the change in voltage is still equal to the capacitance. Okay. Okay, so what is the question again? How much charge must leak off its plates before the voltage is reduced by 100 volts? So you put 100 volts there, and that you can calculate how much charge needs to leak out. Okay? So that's what that equation is telling us. All right, so C is this much charge must leak out for it to drop by 100 volts. C times delta V. And what is C? 20 microfarads. Okay. So that's, and farads times volts is coulombs, so that's 2000 coulombs, 2 millicoulombs. Okay, so 2 millicoulombs need to leak out. All right, so I believe that finishes the problem. Yep.